Okay, so there's gonna be some changes. So I'm still using Paul's online math notes, but just for practice problems, because I found a document that I'll bring up. Alright. So it's this right here. How to take all the math classes you need. And if you look at the Calculus 1 section, we got lectures from Professor Leonard. This Chad right here. Right? So I'm going to watch all 32 videos in this playlist. And after each video, I'm going to go through the practice problems on Paul's online math notes. That's also on here. Right, so I go through all those. And they're not in order completely, kind of. But I'll just like open this, watch the first video, see if I can do any. If not, I'll move on. And yeah, I'll be taking notes as well, watching them. So that's how it's gonna go. First video. Start of new thing. I like market. So what's this video called? 0.1. Let's, yeah, 0.1. Zero point one lines, angle of inclination, and the distance formula. Exciting.
Well, welcome to the official
Oh, too quiet.
of calculus. Congratulations, you made it in the class. Today we're going to talk about a review of a lot of the Math 2 concepts and some basic algebra concepts that you really need to have down in order for you to be successful in calculus. The first place we're going to start is section 0.1, chapter 0. We're going to talk about lines, just basic lines. We're going to go through some families of curves. We'll get into some trig functions, your favorite, right? And then we'll continue calculus. So.
Well, that's a weird lines. There.
What's special about a line? What do you know about lines?
The next 2 points.
Well, they have infinite points, but specifically you need at least 2, right? What else do you know about lines? Do they curve at all? Do they curve, lines?
No.
Do they end?
No.
What do you need to know about a line in order to graph it?
You need 2 points long.
You need 2 points, or you need 1 point and specifically one other thing. You gotta have slope. Lines have slope. They're straight, they don't end, they have slope. In fact, the slope is what we're going to talk about for the first part of today.
Alright, slope.
The slope is pretty much how a line rises or falls. Now, you might have been walked through this a long time ago. We're going to go really quickly through how to find the slope of a line. And we're going to invent the formula ourselves. So let's take a generic line, and we'll pick 2 random points on it. We're not going to be specific on it because in order to create a formula, you can't really say something specific like any particular point. We need to work for all points. Can you tell me, if I've got 2 points, how can I make a distinction between these? What does every point have? Coordinates. What are the coordinates? Somewhere over here. What are the coordinates generally for a point? X1. Okay. So we know that any point that we draw is going to have the coordinates x, y. This one will.
I wonder what he's getting to. I think he's talking about like how to find the slope with 2 points, which is point slope. Or no. Slope. I forget the formula. It's the one where you plug in the 2 coordinates and you get. You can find the slope. It might be point slope. I don't know.
And this one will. But the problem is we need some way to tell a difference between those 2 points. How are we going to do it?
Tell a difference. X1, Y1, and then 2.
What do you think? With some numbers. What are those? What numbers?
1 and 2.
Are they going to go on top of our x or below our x?
Below.
In place.
Subscript.
Now? If I put them up here, we're talking about x to the first power. So we're going to put an x1 and an x2, a y1 and a y2, saying that this is our first point and our second point, whatever those points may be. We can't use real numbers because then it wouldn't work in general for any 2 points. Can you tell me along the x-axis how far is this? 1? 1.
X2 minus X1.
Is he gonna be like, you can't tell or something?
If this is the point x1, y1, how far is that?
X1, Y1. How far? What? I don't know.
Yeah, it's x1 for sure.
Oh. Well.
How
Okay.
far is this point? Yeah, are you guys with me on this? Nudge your hip, you're all right so far. If you're not, go like this. We okay or no? All right. If this was like the point 3, 5. To get to 3, 5, you go over 3 and up 5, right? So then this would be 3. This is not 3, 5, it's x1, y1. So we're going over x1. How far are we going up? Good. And here? Now, when we talk about slope, typically a long time ago when you were first introduced to slope, the teacher probably said, yeah, it's how your line rises or falls. But then they also said, slope is defined as what over what? Let's go ahead, let's try to identify what our rise.
Man, this like drill into our heads, huh? They're like zombies.
Is and what our run is. What would you say would be our...
I'm not writing that down. I'm only gonna write stuff down that I don't know. I'm afraid I'm gonna forget. Maybe I don't know.
rise? This way?
I'll decide later.
This way. So if we find the difference between those 2 numbers over there, we're going to find the rise for our line. What is the difference between those 2 numbers over there? How do you find the difference, this distance here? Sure, yeah, if this was 10 and this was 3, the distance between them would be what? Yeah, you'd subtract them, right? You'd do 10 minus 3. So here we're going to go, well, it's not 10 and 3. It's y2 and y1, so our rise we're going to call y2 minus y1. Can we do the same thing with the run?
I think he's showing how you get to the formula or something, or something like that. I don't know. Or yeah, because the formula is just written differently.
As far as our run, what's that distance
Still forget the name.
represented as?
X2 minus X1.
I thought you were going to answer. Instead you sneezed. I was like, she's off. And then, phew, darn it. Let's hope for a good one. Yeah, we got x2 minus x1 for sure. Does that look familiar? Yeah, if we use the letter instead of the word slope, what letter am I talking about here?
M.
If we use M instead of slope, we got our formula.
Yeah.
Which is kind of, you've seen it before, right? You've probably seen it. Have you seen it invented before like this?
I'm gonna look it up. It is point slope.
If you haven't, well, this is something new for you. If you have, well, you've seen it again. This is how you invent the slope formula. The reason why we couldn't use specific points is because we wanted to be able to. This is how you invent the slope formula. The reason why we couldn't use specific points is because we wanted to be able to plug in any 2 points that I give you, right? So using that, if you call your points x1, y1, x2, y2, you can find the slope for anything. Now, the one reason why I invented this for you is I want to show you that we can actually create an equation from that, an equation for a line from that slope formula. So let's talk just a bit about equations. What we're going to do is we're going to manipulate that formula by fixing one point. We're going to be able to get the formula for a line. So here's what we're going to work.
You know what, I'm gonna write down every formula, at least. And then maybe some other stuff.
with.
That's what
We're
I'll
going
do.
to start with m equals y2
Yeah, okay, we're good.
minus y1 over x2 minus x1. What I'm going to do is I'm going to fix this point. Say this is any specific one point and let the other one float. What that does is it changes this formula into this formula. Instead of y2 minus y1, there's no more y2. You see, here's the thing. A fixed point is a point with a little number under it, a subscript. Like this would be a specific fixed point, x1, y1. This is a specific fixed point, x2, y2. What I'm doing by fixing one point, and only one point, I'm saying that's the one point I'm fixing, x1, y1. I'm going to let the other one be floating. So I'm going to erase that.
I'm not sure if I understand this yet.
Y2 and the x2. That means I'm going to have y minus y1 over x minus x1.
Okay, it's showing how you get the point slope. Again though, I'm not sure if I understand the fixed point thing.
That says one point's fixed. This point is going to be formulaic. It means you can plug in an x and get out a y. You ever seen an equation for a line? About your head, you've all seen it because you're all here, right? It has places for you to plug in x and get out y, doesn't it? So we need that inherently, otherwise we don't have the equation for a line. We have a specific 2 points. We don't want that. We want the equation for a line. Now here's the cool thing. Is there a way that you can solve for y minus y1? How would you get rid of this denominator? Do what now?
Multiply.
Someone said I could just have bad ears. See? Multiply it. On one side or both sides? So if I multiply this by... Oh, that worked. Cool. X minus x1, and over here, x minus x1. Is this gone?
Yes.
You guys are so quiet. Is this gone?
Yeah, they cancel each other out.
For sure. For sure. On the right-hand side, tell me what I'm left with. On the left-hand side, I'm going to reorganize this. I'm not going to have x minus x1 times m. I'm going to have m times x minus x1. You still okay with that so far? Multiplications, commutative, doesn't matter what I have first, what I have second, no problem. Maybe you're not familiar with it written this way, but I'll bet you've seen this before.
Yeah, brother.
Yeah, what is that called? No, it's not slope intercept.
See, everybody gets that mixed up. It's not just me, I swear. I was thinking slope intercept too.
Point slope. Why is it called point slope? Mathematicians are very unoriginal. It's called point slope because it's
There's a point and there's a slope, I think.
named after what you need to complete it. You need a point and the slope. That's why it's called point slope. So by manipulating our slope formula,
So I want to go back to that fixed point thing. It's probably nothing, but I just want to rewatch it.
formula to work with x1. Take a look. What I'm going to do is I'm going to fix 2 minus x1. What I'm going to do is I'm going to fix this point. Say this is any specific one point and let the other one float. What that does is it changes this formula into this formula. Instead of y2 minus y1, there's no more y2. You see, here's the thing. A fixed point is a point with a little number under it, a subscript. Like this would be a specific fixed point, x1, y1. This is a specific fixed point, x2, y2. What I'm doing by fixing one point, and only one point, I'm saying that's the one point I'm fixing, x1, y1. I'm going to let the other one be floating. So I'm going to erase that y2 and the x2. That means I'm going to have y minus y1 over x.
Yeah, that makes sense. So, one point it's not specific, it's not fixed anymore. So he gets rid of the subscript. And then the other's still fixed. And that's just to put it into point slope form so that he can find the slope.
Minus
just 1 point.
x1. You get it. Yeah. For sure. For x minus x squared before. Point slope. Why is it called point slope? Mathematicians are very unoriginal. It's called point slope because it's named after what you need to complete it. You need a point and the slope. That's why it's called point slope.
Alright, back to it.
So by manipulating our slope formula, interesting, isn't it? We use this. We fixed only one point, let the other one.
Actually, 1 second. That reminded me I had to charge my AirPods.
Float worked around a little bit. We now have point slope.
Alright, formula, write it down. Whoa, what did I do? Points, slope. Alright, got it right.
Pretty useful stuff. Shall we do an example? Would you like to see something that we can use this stuff with?
Give us an
I think you've seen
example.
it before. This should be reviewed for you. But let's go ahead. Let's see if we can first get the cobwebs out of your head, because I know you weren't doing math over Christmas break, were you? Or holiday break, whatever you're doing. Were you doing?
Man, I feel pathetic. Just kidding. Let's move on.
Doing math? I was redoing this class.
Same, Under. I'm doing that right now. Well, technically, break hasn't started yet, but I will be.
To make it extra super special for you. You should feel honored. But let's go ahead and try to find the equation of the line that passes through these 2 points. We'll get the cobwebs over our head. We'll try to use a slope formula and then use point slope. Oh, what points? So find the equation. through these 2 points.
Oh, easy, dude. I'll do that right now. So -2, -3, and -2. Okay. Y minus or wait, can I I'll start plugging stuff in. Y plus 3 equals m times x plus 2. Okay. Okay. Oh, can I plug in this point into this? I'm just gonna do that. So y, so 2, and then x, so 8. I'm not sure if you can do this, but half. I don't see why you wouldn't be able to do that, because this is just another y and another x, so yeah, okay, this is what I think. I was scared to do it at first, for some reason. Well, maybe you can't do it, let's watch.
Whenever your teacher taught you how to find the equation of a line, they taught you absolutely have to have 2 things. You have to have one, what? You have to have 1 point, very good. And somebody else, you also have to know the
Slope?
gotta know the slope, or be able to find the slope. Firstly, do we have a point?
Yes.
Actually, we have 2 of them. We're set, right? Do we have a slope?
No.
Is it given to you?
Oh wait, find the equation. So I gotta plug that back. Wait. So if I want to rewrite this, it would be y plus 3 equals half x plus 2.
You right now. Can you find it? Yeah. Go ahead and find it.
Do I want to distribute this? Is that like? I feel like that's not like good form. So that's my final answer.
By the way, I usually do this. I'll walk around the room. If you need help at this point, let me know, because now would be a good time for me to help you. What I want you to do right now is find the slope. If you don't remember how to find the slope, you assign x1, y1 to 1 point, x2, y2 to 1 point, and plug it in that formula. Okay, go ahead and try it.
Dude, I'm not gonna lie, no shade on anybody who couldn't do this. Like, actually. But if I was in this class and I was like doing what I was doing, I was confused, I got this wrong, I would drop the class. No, I wouldn't drop it, but I would be very disappointed, dude. I'd be grinding on my own like the whole year, dude. Cause man, that would suck. Anyway.
Try that right now.
Yeah, obviously, like, if somebody couldn't do that, that's fine, obviously. And I might have got this wrong, so. Let's get through this.
Okay, let's see what y'all did. Just want the slope for now. We'll work on the equation in just a second. So as far as the slope goes, we need to pick one of these points to be x1, y1, another point to be x2, y2. You just got to make sure it goes xy.
Oh wait, I just realized I could just use the slope formula. I mean, it's the exact same thing, right? It's it really doesn't matter, or at least it shouldn't. So what did I get for y2? Should have been 2 minus, so plus 3, 5, x2, which is 8, plus 2, 10, half, like, yeah, okay. I just put it into the point slope for some reason. Same thing though.
And it goes 1, 1, and 2, 2, right? Those numbers got to be together. And you have to have an alphabetical order. You can't go YX. Which is going to be your X1? Do you all pick -2 for your X1? It really doesn't matter, does it? I could pick this one as X1, but then that would have to be Y1. So once you pick one letter, the rest of them have to fall into place. Now typically people just want to make it easy, and they put this one, X1, Y1, X2, and Y2, which I'm guessing most of you did that one. The other way, you're going to get the same exact slope. It's just if you had a negative or a sign, it's going to be in the opposite spot. Not a big deal. Let's go ahead and plug this in. We have Y2 minus Y1. What am I going to write down if I'm supposed to do Y2 minus Y1 right now?
2.
2, like that? Minus, okay, good. So
No.
we're subtracting, but that also has a negative sign. I want to be real careful about that.
Come on, Leonard, you're the professor, man. You can't be making mistakes like that.
I'm going to put in parentheses to show that I'm subtracting a negative right there. What is subtracting a negative? What's that become? Great, okay.
Positive.
Well, yeah, it ends up being addition. And then for X2 minus X1, we're going to have our 8 minus -2. Same idea. What is our 2 minus -3? How much do we get? Over? Can you reduce slopes? Absolutely. What is it?
Yep.
Okay, quick show of hands. How many people were able to find the slope? Good, that's starting to remember, that's fine. If you're not, work on that later. Okay, revisit this, try to follow through this example, see if you're starting to remember, that's fine. Okay, quick show of hands. How many people were able to find the slope? Good, that's starting to remember, that's fine. If you're not, work on that later. Okay.
Alright, my bad. I want to comment on this.
The slope.
What he said.
Good, that's starting to remember, that's fine. If you're not, work on that later. Okay, revisit this, try to follow through this example, see if you can do it on your own, and then come up with that.
What an absolutely base professor, though. Because what I was saying, if I got this wrong, I'd be very discouraged. He's like, nah. He's like, don't be, just work on it. It's like, great guy.
Are we done? We're about halfway there. Okay, we have the slope. Do we have a point still? If we've got a point and we've got the slope, we should be able to fill out
Point slope.
It's actually the same exact formula as slope.
I'm actually so glad these videos start like at this point. Because if it went right in the calculus stuff, I'd be yeah, that'd be bad.
We just have now fixed one point and we have the slope. It's kind of good. So we know we're going to be filling out y minus y1. Check it out. If you already have your y1, you can leave it. If you want to make it easier on yourself and not deal with those negatives, you could use that point. That'd be fine as well. It doesn't matter what point you have after you've already identified your slope. Here I'm going to stick with the same one to keep it kind of continuous for us. So we have y, what am I going to write? Perfect, okay. Again, I'm going to use some parentheses saying that's a negative number in there. Equals, I'm supposed to have my m. What's my m? Uh-huh. And x? Perfect. Let's clean this up just a little bit. We're going to have y plus 3 equals 1/2 x plus 2.
That's what I got.
If it's asking
yeah.
for point slope, you know what? You're done. Okay, that's it. But this isn't exactly the easiest way to graph a line, is it?
Slope intercepts. Okay, he wants us to do that. So y, and then okay, so you just move it over. So y plus 3 equals half x, and this is when you distribute and all that, whatever you want to make it. Slope intercept, I guess. Plus 1, minus 3 on both sides. Y equals half x minus 2. And that's slope intercepts.
Like that. Is there a way we could make it easier?
Yeah.
What would you do? Sure, we want to get rid of those parentheses, we'll distribute that. If we distribute the right side, I'm still going to have this y plus 3, but I'm going to get 1/2 x plus what?
1.
Good. 1/2 times 2, that's going to give us 1. And lastly, last step is what? Yeah, if I do that, I'm going to get y equals 1/2 x. That's something we're real familiar with. We know how to graph that pretty well on the xy axis. What is that called, by the way? Yeah, whenever we have y equals mx plus b, where we have some number times x plus or minus some constant, we know that that's going to be called, that is slope-intercept. And it's pretty easy to graph. It gives you what you need to graph a line very quickly.
I'm not sure if any of this so far is going to be in the Paul's Online Math Notes practice problems, but we'll see. Maybe later on in the video. I know functions is his next video, so that's what I was doing yesterday for Paul's Online Math Notes. So.
And the reason why it's called slope-intercept is that's what you have. That m, well, that's our slope. What's the b stand for?
The intercept.
Yeah, good. Y-intercept. Then to graph it. What we just graphed. How would you graph something with 1/2 x
How I can graph this?
minus?
I think it's gonna be really bad, but yeah. No, I use straight lines. So y-intercept's -2. 1/1, 2, -1, 2. Okay. So -2. This is 0, 0. Then rise 1/2. This is 2, -1. This is not 0, 0. Why? Just because the center doesn't mean it's 0, 0. So 0, -2, and then -1 over -2 here. And that is 0, no, not 0, -2, -3. I think, and then straight line this. So I think that's about it.
That's 2. Can you tell me what is my y-intercept in this case? So when we're graphing slope-intercept, that says if we have a -2, that means we're going down or left. What's that mean? Down. So we know our y says down 2. That says we're going to put a point right there. That's where our -2 is coming from. Next, we use our slope from the point that we just graphed, not the origin, but the point we just plotted, to find our next point. Our slope is, what was it? Is that up or down? Up how many? And over to the right how many? 2. Yeah, the positive or negative tells you whether you're going up or down. You always go to the right. So if we had -1/2, that would say go down 1, but you're still going to the right. You're always going to the right. The plus negative tells you up or down. You with me on this so far?
Yep.
So we're going to go up 1. You all said to the right 2. Now that we have 2 points, we know that 2 points delineates a specific line, unique line. We graph it, we make sure we label this. And we're done.
Make sure to label it.
Show him.
Y equals 1/2 x minus 2.
That's how many people feel okay with graphing these lines using slope formula and the point slope. Good deal, all right. Now there's a couple more things we got to talk about lines before we talk about parallel and perpendicular, which we're going to do in just a second. If I told you that this was a line, y equals to some number, c, where c is a constant. What type of line is that?
Let me think. So if y is the constant, that means there's no x. Okay, so it's like perpendicular to the x-axis, so straight up and down. Vertical. I don't know. I don't know how to. He wants us to describe this.
Well, they're all straight lines, right? They're all straight lines. That's
I would have said that.
a straight line. What I think you might mean is this a vertical line or is that a horizontal
Vertical.
line? Horizontal line. You know the way you can tell what
Is it horizontal?
variable do you have up there? That means it's going to cross the y-axis. Whatever variable you have.
Oh, okay. Wait, so I want to think about this. Because I thought it was vertical. So if you have like y1, y equals 2, y equals 3. Or wait, constant. So that means it stays the same. Oh. So it has to stay the same and the x changes. So it would be like, it has to be like here. This is the constant. C. And then, yeah. Okay, it's horizontal. Alright, I understand.
Have says that's the intercept that you have. So there's no way to have this line crossing the y-axis. Does that make sense to you? There's no way to do that. The only way you can do that and have a constant line is like this. That's a horizontal. So if you have a y equals, that's saying you're going to have a y-intercept at that number and it's going to be horizontal. So when y equals a constant, you're talking about a horizontal line. What's the way I can make a vertical line, just straight up?
Write that down. Y equals C equals, not equals, horizontal line, X equals C, vertical line.
Yep, if x equals a constant, we have an x-intercept. That's a vertical line. Another way you can think about that, if you have y equals, and you try to fit it into this formula, the slope intercept or point slope, you've got a slope of 0, right? There's no slope there. A slope of 0 is going to give you a horizontal line. If you don't have a y, though, that means you're going to have an undefined slope. That means you're going to be a vertical
Wait, what?
slope. That means 0 is going to give you a horizontal line. If you don't have a y, though, that means you're going to have an undefined slope.
If you don't have a Y.
Slope of 0 is going to give you a horizontal line. If you don't have a y, though, that means you're going to have an undefined slope.
If you don't have a Y, undefined slope.
That means you're going to be a vertical.
Oh. Yeah, so X equals C. Okay.
Oh, yeah. Let's manipulate one equation. We'll see if we can put it into slope-intercept form. We'll talk about some parallel perpendicular lines, and then we'll go on to some trigonometry. I can tell you're excited. You excited?
Yeah.
Some of you are giving me death looks right now. You know that? Right here we have an equation that's kind of a standard form of a line. It'd be standard form if we added the 3 to one side, and then we'd have the standard form. Is there a way you can put this into slope-intercept?
Hold up. Let's do, I'm gonna guess no. Actually. So if you look at slope-intercept, where is it? All the way up here? Well, okay, so you can put, or wait, slope-intercept, oh wait, did he say slope-intercept or point slope?
Side, and then we'd have the standard form. Is there a way you can put this into slope-intercept?
Oh yeah. I said point slope. So 2y minus 3 equals negative 4x. 2y equals, I could have just moved them both over at the same time, whatever. Negative 4x plus 3 divided by 2. Y equals negative 2x plus 3 over 2. I don't really want to graph it.
Go ahead and try that for me. Just go ahead and solve for y and make that slope-intercept. We want to make sure you can do it.
Parallel lines. Is that like system of equations we're doing or something?
What would you do first if you're trying to solve that thing for y? Yeah, you're trying to isolate it. What's your first step in doing that here? You could add 3, then you could subtract 4x, and then you could divide by 2. Another way to do it, you could subtract 2y, right? It's probably going to eliminate a step for you. If you subtract 2y,
I didn't think about
you're
that.
going to end with 4x minus 3 equals negative 2y. Now typically we don't like to do that because we don't want to have a negative coefficient in front of y, but we just have to divide by negative. If you're good with signs, you can do that pretty easily. How do we get that y by itself again? Just make sure if you divide, you got to do it
Both
everywhere.
terms.
And you have to have the same exact thing, and you have to be good with your signs. So 4x over negative 2, what are you going to get out of that?
Negative 2x.
How much? 2. And then plus or minus? How much? Equals? Sure, maybe you write that a little bit different to get that in the form that you want it. Y equals negative 2x plus 3 halves. Could you still graph that? Yeah. As a matter of fact, sometimes it's nice to keep it in standard. I asked you to do it in slope-intercept form, but I also want to show you this. If you have this in standard form, which would be that. Have you ever learned the cover-up method for graphing from standard form? You ever seen that before? If you
Wait, is that standard form? I thought it was whenever there's a 0 on the right side. I don't know, whatever.
want to find the x-intercept, cover up your y, divide by 4. You know it's going to cross the x-axis at 4/3. It's easier than graphing it's going to cross. Find the x-intercept, cover up your y, divide by 4. You know it's going to cross the x-axis at 4/3. It's easier than graphing a fraction than going up and over, down and over. If you want to find the y-intercept, you cover up the x, divide by this number, positive 2. That's going to cross the y-axis at positive 3 halves. You can graph a line like that as well. So just a little
Wait, did you say 4/3?
y-intercept, you cover up the x, divide by this number. If you want, it's easier to do
Hold up.
that. Have you ever learned the cover-up method for graphing from standard form? You ever seen that before? If you want to find the x-intercept, cover up your y, divide by 4. You know it's going to cross the x-axis at 4/3.
I think you misspoke.
It's easier than graphing a fraction than going up and over, down and over. If you want to find the y-intercept, you cover up the x, divide by this number, positive 2. That's going to cross the y-axis at positive 3 halves. You can
Yeah, that makes sense because you plug in 0 for the opposite variable anyway. So why not?
graph a line like that as well. So just a little refresher on those. Those show of hands, how many people feel okay so far on our lines? You still all right? You awake still? This should be review. This is review for you. I know some of you are thinking, where's the calculus? Just wait for it. All right, the calculus is going to come, whether you want to or not.
True.
Just hang on for a second. Enjoy the nice slow stuff, but really absorb this if you're a little rusty on it. What do you know about parallel lines?
They don't cross, and you can find the slope. If you get 2 parallel lines, you know both. What is it? There's something you can do where you can find the slope by just having like different parallel lines. Well, we'll see.
That's actually the definition. Did you hear him over there? We have the same exact slope. That means we have parallel lines. It's kind of like climbing stairs, right? The way stairs work is they're parallel. That means you're going up and over the same rate. Otherwise, on these stairs over here, if your stairs didn't go up and over, you're gonna be like this. You're gonna be like, oh, these are nice. These are nice. Son of a gun, you know. If they were different slopes, they intersect somewhere. We don't want that to happen for stairs. We don't want that to happen for parallel lines. So when we talk about parallel lines, what we're talking about are lines that have the same exact slope.
Oh, I know. So I think I did this one problem where it's like you have 2 points of one line, and then you have the slope of a parallel line or something like that. And I think this is the same slope, so I think that's what I was thinking of.
Do perpendicular lines have the same slope?
No.
No, they don't. Actually, perpendicular lines meet at a very specific angle. What angle do perpendicular
90
lines
degrees.
meet at? So if one line's like this, the other line's got to be like that, right?
Yep.
It means if one slope's positive, the other slope's negative. So we know that's going to come into play. Also, it's not just a negative slope. That's going to be something like this, right? That's not going to cross at 90 degrees. We want to make it actually just a little kicked over. How do I make it so it meets exactly 90 degrees? It's not only negative, but also a...
Negative reciprocal.
Very good. A couple of you said reciprocal. So perpendicular lines are lines where the slopes are negative reciprocals of each other.
I don't even know what that means, to be honest. I've heard it before, but...
Okay.
How did he write in all caps like that?
That begs the question, if I give you an equation, can you find a line that's parallel and or perpendicular, or perpendicular to a given equation? Can you guys do that? Let's try that out real quick. That'll be our last little...
I want to look up what negative reciprocal means. The negative reciprocal of a number is to take -1 and divide by the value. Oh, okay, so you have so say your slope's 2/3, it would be -3 over 3/2. Okay, I do remember a reciprocal. The negative reciprocal is like flipped and then change the sign. So that does make sense. And then if it's going like one way, it goes the other way. 90 degrees, whatever. Surprised that dude's smart if I said that. Haven't got that.
timid review problem. Hopefully these have been timid for you. We haven't even made it 30 minutes in.
I'm gonna write that down. Spell it. Reciprocal. I'm just gonna write down like that example. So like half -2 over 1. Make it easier. Perpendicular lines where a slope are negative reciprocal to each other. Perpendicular lines have negative reciprocal slopes.
We're going to get to some training in just a bit.
Of each other.
Yeah. So let me say that I want to find the equation of a line that passes through this point. And parallel to
write this down. 6, 7. So it passes through 6, 7. Oh, it's parallel to
this.
Okay. So I think this is basically that one problem I was talking about. So if it's parallel, that means you can find the slope of this equation. It'll be the same as the equation of this point. So 3y equals negative 2x plus 12 divided by 3. Y equals negative 2/3 x plus 4. Okay, so then slope is negative 2/3. Plug that into point slope. Y minus 7 equals negative 2/3 times x minus 6. What's the question exactly? Find the equation. So he put it in slope intercepts the first time, so I'll do that too. 2/3 x plus 4 equals y minus 7. Add the 7 on both sides. Y equals negative 2/3 x plus 11. So yeah, basically the thing I was talking about earlier.
Find the equation passing through a set point and parallel to a given equation. What's the two things you need for sure in order to make the equation of a line? Slope and what now? Point. Do I have a point?
Yes.
Cool. Do I have a slope?
No.
Do I have a slope right now? No. Not yet. I got to work on it, but could you find that slope?
Yes.
Let's find the slope. Go ahead and do that on your own real quick. Give about 5 seconds. You guys should be pretty good at this. Is the slope negative 2? No, what am I missing? That's the reason we talk about slope intercept, right? Is to find that slope very easily. Your slope's negative 2/3. Now what I'm asking for is the equation of a line that's parallel to that line, but now goes through that point. So what slope am I going to use if I want to find the parallel line to this?
2/3.
I'm going to use 3/2 if I want the parallel to this. Parallel lines have the same slope. So what we're going to write down, we're going to find our slope. We want the parallel slope. So we're going to write down the parallel slope. If it's parallel, it's going to be exactly the same. We know that our m is going to be negative 2.
Oh, I don't understand what that guy said. I think he was finding the perpendicular slope or whatever. Because, yeah, he said 3/2 or whatever.
Thirds. Now what point do we use?
I'm guessing that's what we're going to be doing next.
What point do we use? Speak up. What point do we use? Okay. Does this 4 have anything to do with this problem, actually?
No.
All we cared about was finding the slope. Once we have the slope and we've already identified a point, wow, we can just plug that into our point slope formula to find the equation of our line. So we'll do y minus 7 equals negative 2/3 x minus 6. Quick show of hands. How many people feel okay solving for slope? Give me a head nod if you understand that the slope we're supposed to use is still negative 2/3 because we want to find a parallel. Do you see where the 6 and the 7 are coming from? Good deal. Can you work that out and make that?
Dude, if I had a teacher as good as this guy, that would be wild. It's not too late.
Slope intercept for me. Okay, let's do that together. I know that y minus 7, that's going to stay there. On the right-hand side, tell me what I'm going to get. And then plus or minus, what do you think? Plus how much?
4.
Good. Final step, if we add step 4 because we get 2/3 times 6. 2/3 times 6, you can simplify the fractions, or we get 12/3, that's 4. Add our 7 to both sides.
I think that's what I got.
And we're done. What if I change the problem, and instead of having parallel, I asked you to do perpendicular? Could you?
You'd find negative reciprocal, which would be 3/2, and then you just plug that in to the equation instead, so it'd be similar.
Still do it. Let's talk about the only changes that would occur up here, okay? I'm not going to change the whole problem, I just wanted to walk you through it here. If I'm talking about perpendicular, would this process change?
Y-intercept would also change.
Would this change? What's that going to become?
3.
Okay, so this would become 3/2. So here now we're talking about perpendicular. Perpendicular.
I actually didn't know about the perpendicular thing, so it's pretty cool.
Would the 7 and the 6 change? No, we're just talking about slopes. About this is parallel perpendicular only has to do with the slopes. This would change to our 3/2. This would change to our 3/2 x. It'd be minus how much? Minus 9. And if we added 7 to both sides here, we get 3/2 x minus 2. So we can find both the parallel and the perpendicular slope. Do you feel okay about our basic lines so far? Would you like to learn a little bit about angles of inclination and use a little bit of trigonometry here? And you're
Oh,
like,
whoa, buddy. Oh no. Every time I hear trig, I freak out, dude.
no, not really.
Let's calm down,
Too
Leonard.
bad. We can do it anyway. Let's talk about angles of inclination. We're going to use it at some point.
I don't even know anything about that. Gotta be educated.
Are there any questions before I erase any of this stuff? Are you sure? Are we having fun yet?
Oh yeah.
Would you rather be in here than out there in the rain? Some of you are like, no, I'd rather be in the rain, honestly, right now. I prefer that. Just lie to me. Just lie and say, yes, this is awesome, Leonard. I love this class. You're the best. Thanks, guys. Appreciate it. If you did that, I would just watch this video over and over again and have you go, thanks, Leonard, you're the best. Say, yeah. Thanks, Leonard, you're the best. Yeah. Thanks, Leonard, you're the best. Yeah. See, I just have a funny loop. I do it with my workout. Thanks, Leonard, you're the best. Bam. Thanks, Leonard. Bam. So cool. I know, I'm a dork. Oh, my angle of inclination. Let's
Write that down. Angle of inclination.
talk about how we can use angle of inclination and relate it to a slope. We're going to start with some line, random line. When I talk about the angle of inclination, what we talk about is the angle that any line makes with the x-axis. So the angle of inclination, these actually would be the same angle. If you take in geometry, you know that those are the same. We're really just talking about this one now. We'll call it theta. We want to find some way to represent this line as having that angle,
See, any
You know that those
angle
are
that
the
crosses
same.
the x-axis?
The angle that any line makes with the x-axis. What we talk about is the angle that any line makes with the x-axis.
The angle that any line makes with the x-axis. Couldn't it be the obtuse angle too?
So the angle of inclination, these actually would be the same angle if you take in geometry. You know that those are the same. We're really just talking about this one now. We'll call it theta. We want to find some way to represent this line as having that angle. If we think about the x and the y-axis, notice that
Maybe it's only on the right side or something? I'm not sure I understand the definition. Because wouldn't this be an angle too? It's like crossing into the y, kind of. If he doesn't explain it, I'll look it up.
this we could represent as a change in x. You guys have seen that terminology before, the delta x change in x?
Wait, what?
And the x and the y-axis, notice that if we think about the x and the y-axis, notice that this we could represent as a change in x. You guys have seen that terminology before, the delta x change in x? And this would be, well, the change in y.
Okay. Real quick, gonna look up angle of inclination. Twitter. The angle between the equilateral plane of the Earth and the orbit. Okay, I don't think that's the same thing. An angle of inclination is defined as the angle between the equilateral plane of... Same thing. What is the definition of math? The angle formed by the x-axis and given a line. Measured counterclockwise from the positive half. The angle between the line and the positive direction of the x-axis. Okay. So it is kind of what I thought. It's only on the right or the positive side.
Now think back to your trig days. This is just basic trigonometry. Is there a trig function that relates this angle?
Adjacent, opposite over adjacent, tan.
And these two specific sides. Remember, this would be a 90 degree angle. What does that? If this is a triangle, which it is, what's this side called? That's hypotenuse. What's this one?
Opposite.
According to this angle, that's the good. And this one is the which one relates adjacent and opposite?
Tangent.
Not sine. Sine would be opposite over hypotenuse. Tangent does. Or cotangent. We don't deal with cotangent. Cotangent's adjacent over opposite. We want to deal with probably the easy one, tangent. If we talk about tangent, the tangent of that angle is equal to the opposite over the adjacent. Nod your head if you're okay with the tan, opposite over adjacent. If you're not, you're definitely going to want to review your trigonometry before attempting this class. You're dealing with a lot of trigonometry in here.
I'll write that down, I guess.
But here's the cool thing. What do we already define as change in y over change in x, or
I see what he's doing. It's y over x, right? And he's gonna use like sine over cosine or something like that. I think he's proving something like that.
rise over run. What do we always already define that as? So then we have this relationship. We know that.
Yeah, I think what I was talking about is like the unit circle thing. But that does make sense.
Tan theta, well, that's delta y over delta x. But this is also the same thing as slope.
That's kind of crazy. What?
Or m. If you bring all this together, slope's equal to tan theta.
Bruh, what? For angle of inclination, huh? It's kind of crazy.
Do you see the relationship between your slope and your angle of inclination? It's the same thing. Well, it's the same as the tangent of that angle of inclination. Because tan is defined as opposite over adjacent, and so is slope. We can.
So if you find that theta, you tan whatever the theta is, then you get your slope. Kind of crazy.
Make that jump. What's kind of cool is it says that if you know the angle, well, you can find the slope. Can't you?
Yeah.
If you know the angle, you can do that in a calculator. You'll be able to find the slope. If you know the slope, but you can find the angle. Those things are intertwined. They're equal to each other along with that tangent. So shall we try one? Would you like to see an example of how this is done? Would you?
Yeah.
You're the most mellow class I've ever had. Would you like to see one? Bring it on. Let's say that your angle is 30 degrees. Someone quickly, 30 degrees
I'm not.
as radians is what?
Oh, it's 5 or 6 or something. I don't know. Alright, I'm back. Is it? Yeah, because 18 divided by 6 is 3 times 10, 30. Easy.
Good. The same thing as 5 or 6. Yeah. I want you to find the slope of the line.
Wait a minute. What would that be? I don't have unit circle memorized.
Has an angle of inclination of 30 degrees or pi over 6. Here's how you do it. We know for a fact that m equals tan theta. Don't forget that. Okay, that's your equation. That's what you do now. You know that the slope is equal to the tangent of that angle. What's our angle?
30.
What's our angle?
30 degrees.
30 degrees. So if I plug in my 30 degrees, or I plug in my pi over 6, that's the same angle, okay? If I plug that in there, then I know the slope I'm looking for is equal to the tangent of pi over 6 or 30 degrees, whatever you want to work in. I like pi over 6. Now, all those with your unit circle tattooed on your right arm, okay, look down there. Can you tell me what tangent of pi over 6 is? Can you tell me what tangent? Remember, tangent, you have to define a sine over cosine, right? So you're going to find sine of 30 degrees or sine of pi over 6, put it over cosine, or have them memorized.
Okay, wait, let me think. 6, 4, 3. 1, 2, 3. 3. Square root of 3 over 6. I don't know. I'm just trying to memorize units for a question. I don't know.
Put it over cosine of pi over 6 or 30 degrees. Look at you in a circle. If you have one, you should have one. You need one. Honestly, you should tattoo it on your forehead backwards. That way you look in the mirror, you can memorize it. It's a good idea. It's a good idea. I haven't done it personally, but I'm waiting for someone to actually do that. It's pretty classic. Tangent of pi over 6 is sine over cosine. The sine of pi over 6, 1/2. Cosine of pi over 6, root 3 over 2. That's what those should.
Okay, there's no 6 in the denominator. I was thinking of something else. I think the radians or something. I don't know.
Correct me if I'm wrong, but I think.
It was a square root of 3 though.
I'm doing this on the spot. Good. All right. Can you simplify that a little bit?
2 over 2 square roots of 3.
Yeah, those 2's are actually going to cross out. You know, divide those fractions, complex fractions. You're going to flip that, multiply. The 2's are going to be gone. What you're going to end up with is 1 over the square root of 3. Or if you rationalize the denominator, you know how to rationalize denominator, right? Multiply by root 3 over root 3. You're going to get root 3 over 3. Strangely enough, that's your slope right there. Your slope is root 3 over 3.
But this only works for angle of inclinations. So, I think.
All right, let me recap. Did you get that? That was funny.
So I'll write down the example, I guess. What example am I on? Does it matter? No. So theta equals 30 degrees, which is pi over 6. M equals tan theta, M equals tan 30, which is half over square root of 3 over 2, which is 2 over 2 square roots of 3. Cancel out the 2's, 1 over square root of 3 times square root of 3 over square root of 3. Square root of 3 over 3 is slope.
Oh.
Come on. Stand up next. Let me recap.
Oh.
Come on.
It's a good one.
Stand up next time. Maybe you'll get it. I honestly will recap though. Here's what you do to find the slope if you have the angle of inclination. You take your angle, you plug it in, and you figure out the tangent of that angle. That's honestly it. I mean, if you can find the tangent of pi over 6, you have your slope. That is your slope, all right? Now, can you go backwards? That's going to be another question for us. What if I said, I have now...
I guess you can.
I have a slope of -1.
Okay, let me think. Well, -1 equals tan theta. Oh, so is this like inverse tan? Tan -1 -1 equals theta or something? Maybe. So let me use the calculator. Could be totally wrong. -1. Wrong mode. And add. I have adds on my calculator. It's goofy. -45 degrees. I'm getting negative 45 degrees. So
Can I find the angle of inclination? We only have one equation. The only thing that we know is that the slope equals tan theta. Over here we knew the theta, right? We were looking for the slope, the m. Over here we know which one?
the M.
We know the m. So notice we're using the same exact equation. Here we knew our angle. Well, you could have put 30 degrees here very easily and done the same exact thing. Here we know our m. We know negative 1 equals tan theta. How do we find theta? You can do tan inverse, sure, of both sides. Take it to the left. We do tan inverse of negative 1 equals theta. If you do tan inverse of both sides, it would look like this. You'd have tan inverse. You'd have tan inverse.
Oh, they
Tan
cancel
inverse
out.
of tangent, gone. You have theta. Tan
I never even understood how that worked. I was just like, oh, tan inverse.
inverse of negative 1, that's what we have right here. This is what the question asks you, okay? Here's this in plain English. It says, I want you to tell me the angle so that when I take tangent of it, it's going to give me negative 1. That's what tan inverse says. It's
Oh, that makes so much more sense. So you have tan theta equals negative 1. Well, when you have take tan inverse of a negative 1, you're saying you would find the angle of negative 1. The tan theta, you know.
it's kind of a backwards way of looking at it. It's saying, find me the angle. That way when I take the tangent of it, it's going to give me the
Yeah.
value of negative 1. Do you understand the question?
How he
there?
said it.
It basically goes down to look at the unit circle. Find out where sine and cosine are the same, but have different signs. Because you know tangent is sine over cosine, right? So you look at your unit circle. Find out where it's, or what would we have? It's two of them. I don't remember the exact one. But find out where you have sine and cosine exactly the same, off by a sign. That will give you negative 1. Do you have your unit circle out?
Yeah. 3 pi over 4.
3 pi, that's exactly right. Oh yeah, that's right here. So this happens where your sine, your cosine are the same but off by a sign. That's root 2 over 2 over root 2 over 2. That's where that happens on your unit circle. So check that out later. If you don't have your unit circle handy, you're going to have that same exact value, only this one's going to be negative. That happens twice actually, and if you're confused as, well wait a second, don't I get 2 of these same values? Yeah, you do, but think about what
Where
you
you watch
actually
this for?
get.
I kinda
You know
understand it.
tangent
Not
is
sure.
sine over cosine, right? So you look at your unit circle. Find out unit circle. Find out where sine and cosine. When I take, it's kind of a backwards way of looking at it. It's saying, find me the angle. That way, when I take the tangent of it, it's going to give me the value of negative 1. Do you understand the question there? It basically goes down to look at the unit circle. Find out where sine and cosine are the same, but have different signs. Because you know tangent is sine over cosine, right? So you look at your unit circle. Find out where it's, or what would we have? It's 2 of them. I don't remember the exact one. But
I was just zoning out again. Huh?
but have different
My bad.
signs. In a circle. Find out where sine and cosine are the same. It basically goes down to look at the, it's going to give me the value of negative 1. Do you understand the question there? It basically goes down to look at the unit circle. Find out where sine and cosine are the same, but have different signs. Because you know tangent is sine over cosine, right? So you look at your unit circle. Find out where it's,
Okay, I understand what you're saying then now. Because if it's 1 or negative 1, they gotta be the same. Because sine over cos, sine cos gotta be the same, and one of them's gotta be negative. So
or what would we have? It's 2 of them. I don't remember the exact one. But find out where you have sine and cosine exactly the same, off by a sign. That will give you negative 1. Do you have your unit circle out?
Yeah. 3 pi over 4.
3 pi, that's exactly right. Oh yeah, that's right here. So this happens where your sine, your cosine are the same but off by a sign. That's root 2 over 2 over root 2 over 2. That's where that happens on your unit circle. So check that out later. If you don't have your unit circle handy, you're going to have that same exact value, only this one's going to be negative. That happens twice actually, and if you're confused as, well wait a second, don't I get 2 of these same values? Yeah, you do, but think about what you're actually doing. You're trying to find the slope of a line that goes like that, right? It's going to cross two quadrants. It's going to have the slope here and there.
Oh.
One's going to be positive, one's going to be a negative way of
Very
looking at
true.
an angle. They're all the same, though. 3 pi, what'd you say, 3 pi over 4?
Yeah.
3 pi over 4, or the negative version of that, used as a reference angle. So here we go. We got that negative 1, so we know that this happened when theta was equal to 3 pi over 4. Or if you want to translate that, that's 135 degrees.
Oh. How'd I get negative 45 or whatever? I don't know, but if I looked on the unit circle. Actually, you know what? I'm gonna pull it up. I have it right here actually. Alright. So negative. Or it could be either one. That's why. It could be negative 45 degrees or it could be 135 degrees. Either one of the, because like you said, it's the same slope. So.
So either way we look at this, we can find slopes from angles.
So I'll put that back. And 135 degrees, or and what are the radians? For negative 45, it's 7 pi over 4. For 135, it's 3 pi over 4.
We can find angles from slopes. I'd say that this one's probably a little bit more tricksome for you because you're going to actually have to do a little bit of work on it. This you could probably just plug in a calculator. If you memorize like the 0.877 thing, you know, that's like 3 over 2, yay. Or whatever you
Wait, what?
because you're going to actually have to do a little bit of work on it. Look at this. We can find slopes from angles. We can find angles from slopes. I'd say that this one's probably a little bit more tricksome for you because you're going to actually have to do a little bit of work on it. This you could probably just plug in a calculator. If you memorize like the 0.877 thing, you know, that's like
That's
3
me.
over 2, yay.
I remember.
Or
I
whatever
memorized that already.
Does anyone but me? I memorized those. I don't want to look them up. But if you do this on a calculator, it'll actually work out for you. It probably won't give you the square root of 3.
I thought that was just a bad way of doing it, but it sounds like that's literally what you have to do
But you can figure that out.
unless you look it up.
Here, you're going to have to use a unit circle. If they give you a slope, you're going to have to find the angle to which sine over cosine makes that value. It's going to be something, you might have 2 of them. It's not going to matter, that's the same exact value. You're going to have to find the angle. Here, you're going to have to use a unit circle. If they give you a slope, you're going to have to find the angle to which sine over cosine makes that value. It's going to be something, you might have 2 of them. It's not going to matter, that's the same exact value of the angle. Choose either one of them, it'll work out the same. But find the angle to which you're getting that value. Do you guys see that the process here? I know I went very quickly through this. Do you see the process? Yeah or no? How many people feel okay with this? Does it take a little bit of work to get handy on that? Yeah, probably a little bit more work to get handy on it. Let's see, one more thing I want to go over. Let's talk about the distance formula real quick. It'll wrap up our very first section here. Are you sure there's no questions on angles of inclination anymore? We get time. So if I give you this on a test, and I say, I want you to find the slope if the angle is pi over 3, you do it? Could you do it if you had a unit circle?
Yeah.
Oh, okay. That's a good question. If I say the slope is 1/2, can you find tangent where the angle would give you 1/2? Could you do it with a unit circle? Okay, practice that stuff. That's what I'm looking for.
On a test, you get the
I don't care. Sure. To be honest with you, this is very much review stuff. What I'm trying to get you to get back familiar with the tangent, sine, cosine, secant, cosecant, cotangent ideas, because we're going to move way past this. We're going to be using this within some problems, all right? So this isn't going to be a problem. This is going to be within some problems. You get it? It's kind of like factoring isn't everything in algebra. You just use factoring in everything in algebra. You get the analogy? So that's kind of what we're doing here. We're going to use a lot of trigonometry in this class. We're going to be doing things called derivatives and integrals, and they're all going to involve trig functions. So you got to know your trig pretty well to be successful. People say that you go to calculus to finally fail algebra and trigonometry. Okay, you made it this far, but it's not the calculus that's going to hold you back, I promise. It's going to be your algebra, and it's going to be your trigonometry.
Bro, I'm scared. Everybody says that, dude. Everybody says algebra and trig. It's gonna suck.
Yeah, I guarantee it. The calculus is actually quite easy. It's those concepts put together with calculus that makes it kind of hard. So if you're good at algebra and trig, you're gonna be fine. Absolutely fine. You stick with this class.
Is anybody good at algebra and trig whenever they go into calculus? I don't think that's a thing. It can't be.
Okay, shall we distance formula in about a minute and a half, and we'll call it a day? Let's do distance formula. We're going to do it the same way that we did our slope formula, which is we're going to pick two random points, x1, y1, and x2, y2. Only this time we're going to find the distance between them. If we have the x1, y1, and x2, y2, well, we for sure know that's x1 and that's x2, and this is y1 and that's y2. What we want to do now, though, is use something that relates this side, and that's a right triangle. What relates to that?
The trig thingies. Or something.
Pythagorean theorem, absolutely, you're right. Right. If we call this our distance, here's what we can say. We know that this length is x2 minus x1 by the same step that we just did with slope.
Okay. I never knew how distance formula worked, so.
Formula. We know that this distance is y2 minus y1 by the
No, I'm writing this down. This is some good stuff.
same stuff we just.
Straight line it. So x1, x2, y1. So much for straight lines. Y2. So this is y2 minus y1. This is x2 minus x1. This is the distance between them, or d. And this is the point.
Just use our slope formula.
I'll write down. Distance formula.
This is the length. This is the length from those corresponding points. We want to find the distance. If we do Pythagorean theorem, we've got d squared equals. What's Pythagorean theorem say?
So d squared equals x 2 minus x1 a squared, wait, a squared plus b squared equals c squared, so plus y2 minus y1 d equals square root of this, so x2 minus x1 plus y2 minus y1. Yeah.
Side 1 squared for side 2 squared equals hypotenuse.
Sure, yeah, a squared plus b squared equals c squared. Some of you know that, or I prefer a leg squared plus a leg squared equals a hypotenuse squared, because that tells you what you're doing, right? So
Oh. Yeah, that is a little bit better. Better way of saying it.
if we
Never
take
heard
a
that.
leg squared, that's this, and a leg squared, that equals the hypotenuse squared. I already have that. Here's my first leg, that's the distance, squared, plus the second leg, that's the distance, squared. Can you guys see the Pythagorean theorem at work here? Do you guys see the leg squared? Yeah? This is one leg, right? I'm just squaring it. Here's another leg. I'm just squaring it. And that has to be, by Pythagorean theorem, equal to the hypotenuse squared. So we got that. The only thing we need to do now, get rid of the square. How do I get rid of the square? Yeah, that just means the whole thing. Now we are going to omit the plus minus because, well, we can't have a negative distance. That doesn't make any sense. So
Oh,
we're
yeah,
just going to have the
forgot about
square root of this entire thing. D equals, by the way, oh, here's a good
Or wait,
question.
did I cancel out the... No. I forgot to square him, actually. To begin with.
For you. See where you're at. Will this square root get rid of this square and that square?
Yes.
What do you think?
Wait, maybe...
Does it?
Yeah. I think it does. Because if you think, like, this is d squared, so you want to do that on both terms, right? Because if you're square rooting d squared, you want to do that to both terms. Like if there's like a 3 in front of you, you want to divide by 3 on like every term or something. Could be wrong.
Does it work that way across addition? There's multiplication? Sure. Addition? No way. No bueno.
Oh.
Can't do that.
Well,
And that's our distance formula.
yeah, I never.
You know what? I'm not going to do an example for you
I didn't
because
know
it
that.
works really, really, really simple.
I wonder why. I wish I knew how to like find that out. I have no idea though. I'll finish it.
Similarly to our slope formula. Would you be able to, if I gave you 2 points, would you be able to find me an x1 and a y1? And an x2 and a y2? And plug them in? And not mess the signs up, right?
Yeah.
You just square this value, you square that value, you add them. Of course, it's going to be positive, right? Because you're squaring something, and adding it. Just don't forget to take the square root. You can either leave it in terms of square root or approximate and give me a decimal answer. How many people feel pretty good about what we talked about today? All right, that's good.
Oh, it's okay. We're not going to an hour and 37-minute video right after that. What's this longest one? There's one for 3 hours. It's gonna be fun. Alright, so 3 hours is like his max. Most of them are like an hour and a half. Okay, let's see what Paul's math notes thinks we can do. We didn't do functions, inverse functions, trig functions maybe? Solving trig equations. I don't think that's what it's talking about there. I'll pull them up there and make sure. I think the solving trig equations thing is like with that trig identity sheet. Exponential functions, nope. I don't think there are no functions in that, huh? Yeah, this video is on functions. Exponential and logarithm equations, no. Common graphs, maybe. Alright, let's check it. Oh crap. What did I get rid of? This one. Oh, that's it. Without using a calculator, find the solutions to the following equations. If an interval is given, find only those solutions that are in the interval. If no interval is given, find all solutions to the equation. Yeah, I don't know about this. If I get through all these videos and I can't do like most of the Paul's Online Math Notes things, then I'll definitely go back and read. I'm sure I'll be able to do like most of it though. This isn't a set of problems, right? Yeah. See the solution for this. Because we're dealing with sine in this problem, we know that the y-axis represents sine. We're looking for angles, so we'll have a y-coordinate of half. Okay. So this means we'll find an angle in the first quadrant. And second quadrant that we can use angle in first quadrant to find. Clearly, the angle is pi over 6. It's basic symmetry. You see the terminal line for the second angle must form an angle. You know, I'm gonna skip this one for now. Solving trig equations with calculators, like that's like the same thing but harder. Not harder, but different. Oh, here, without using a graphing calculator, sketch the graph of each of the following. And this is function, so I don't know why I pulled that up. So we can do this. Oh wait, they start getting a little. See the notes for this. I mean, like, I could do this, probably, but... You know, okay, okay, this is what I'm gonna do. Right. I'm gonna watch this video, see if I can do the practice problems. If not, I'll watch the 0.3, 0.4. Alright, if I get through all these, I still can't do any. Then I'll read through the notes and do them. So I'll do both. I'll watch videos and read notes, do problems. Which would take a while, but I'll make sure I can fit it in somehow. I'll watch like a little bit, like maybe 5 minutes of this.
So we've just talked about lines. We're going to be a little bit more general. Today we're going to talk about section 0.
section 0.2 functions. I think once it gets out of the review, 'cause I feel like people do their reviews a little bit different. I think then everything will start matching up better. So then maybe I wouldn't have to read the notes. I just watch the video.
Point two, we're going to talk about functions. Now, here's the deal. Anytime you have, such as one variable depending on another one, such as like y depends on x for most of our functions, where y is dictated by what you put in for x, some independent variable x and some dependent variable y, we can call that a function. The only thing that you really need to have for a function is that every input has one output, not two outputs. Otherwise, you don't have a function because you plug in a number and you wouldn't know where to go. So when we say a function, we mean some expression where each input determines exactly one unique output.
Alright, function. Each input equals exactly one output.
Usually for inputs, we see those are like x's. So typically that's an x. So some expression where each input x has exactly one unique means doesn't happen again, one unique output. And we typically call those y's or f of x for us. You know, we can represent functions a lot of ways, though. We can represent with tables, graphs, formulas. One time I was fishing and I caught 4 fish, and because I'm a math dork, I made a table of it. Because you don't do that? Is that not normal? Anyway, here's one example of a function, very easy function. Here's my fishes. I think that's fish. Fish caught and the number of pounds that they were. So my first fish, second fish, third fish, I caught 4 that day. First one was 3.2 pounds. Not bad. Next was 1.4, then 2.8, and then I caught a massive bass for 7.3. That's a good day. Good day. Threw them all back. Threw them all back. Firstly, let's define what the inputs and outputs are for this particular. Well, we're going to see if it's a function.
So you plug in an x of 1, you get 3.2. Plug in a 2, you get 1.4, and then all that.
In just a second. Firstly, my inputs are, well, the fish that I caught in this instance. The outputs would be, well, their weights when I weighed them, because the scale would be like my.
This wouldn't be a function though. I might be thinking too deep into this. Well, this would be this table right here, I guess. But like, if you, this is kind of stupid. But if you had a fish, 2 fishes that weighed exactly the same, well, then it wouldn't be. So there would be they wouldn't be unique.
Function, right? I put my first fish on there, it'd give me a weight.
I guess this
my
is.
second fish on there, it'd give me a weight. Now, the question is it a function? Is it a function? Does each
So far,
each
yeah.
fish have one specific weight? Yeah. Okay. You know what? I need to erase something right here. Exactly one, not unique, but one output. Unique output would be a one-to-one function, and we're not there yet. So, when we say it has one output,
Wait. A one-to-one function? Exactly one output. Oh, so wait, it doesn't have to be unique. Oh, okay. Well, no, it does kind of though. Wait. Man, now I'm confused. What's a one-to-one function? One-to-one function is a special function that maps every element of the range to exactly one element of its domain. Okay, so if it's a function, if you plug something in, it has one output. If I give you like two y values, yeah. Because if you like said like y squared equals 2x plus 1 or something, right? Like I think some paused online math notes yesterday. Then this wouldn't be a function because y equals square root of 2x plus 1 plus or minus. Right, that's two different values. So it doesn't have to be unique. You just have to get one value.
That I don't have fish number 1 weighed 3.2 pounds and 4.7 pounds. Because you'd say, how much did your first fish weigh? I'd say 3.8 or 3.2 or 4.7. Would that make sense to you? Well, no, seriously, how much your fish weigh? 3.2 or 4.7. And you're like, that doesn't make any sense. You're giving me two weights for the same fish. Does that make sense to you? Would that make sense if you asked me that question, how much did your first fish weigh? And I said, oh, well, either 3.2 or 4.7. He said, well, aren't we talking about your first fish? Yes, we are. 3.2 or 4.7. You're like, well, if I'm having dinner with you tonight, I need to know if I'm going to be hungry at 3.2 pounds or if I'm going to be satisfied at 4.7. I go 3.2 or 4.7. That doesn't make any sense, right? I have to give you a specific weight for that one fish. That's what a function does. It says if you say fish number 1, you're talking about one specific weight. Okay? Maybe I should say the word specific output, not unique, because one unique output, we will be talking about one-to-one in just a little bit. How about number 2? Does number 2 give me out just one weight?
Yes.
Yeah, it doesn't say 1.4 and then something else over here. That would not be a function. So this thing is a function. Any fish that I have, it has one specific weight that we're talking about. If I did this, would it still be a function?
Yes, but not a
That's
one-to-one
yeah,
function.
Yeah, it would be a function. This fish 4 weighed 3.2 pounds, not something else. It doesn't matter that these things are the same. That can happen. Let me give you, for instance, as far as a graph goes. That right there has the same output at several different spots, right? That would be some sort of an x squared. It says if I'm at this point or this point, I still have the same exact output. That's okay. This is still a function. We're going to talk about vertical lines.
And that's why on that one thing I saw it said if it doesn't pass the horizontal line test, then it's not a one-to-one function.
That's too. It's a function.
I'll get a 7:05, so then I only have an hour 30 minutes left.
It wouldn't be a one-to-one function. It wouldn't pass a horizontal line test, but it would be a function. We can also talk about functions. Really, we don't see fish caught normally. We see some sort of function like this, especially if you're doing any mathematical modeling, you might see this, where you have a set of inputs, our x's, you got a set of outputs. That thing would be a function. Every one of our inputs or x's has one output. How you would say that it wouldn't be a function if you came back and did something like this. Would that be a function?
No.
No. If your inputs are repeated with different outputs, well, then you don't have a function there. So that would be a no bueno. Sometimes we actually have formulas too that are functions. This is a function. What is that, by the way?
Think about that.
Sure, and it's a function because
But if the a was squared, it wouldn't be a function.
give me a radius, it's going to give me out one area, isn't it?
And what is that? Like, for a circle? Circle formula. Yeah.
So our area depends on the radius that you have for your circle. It's not like I say, you have a radius of 3, what's your area? And you give me 2 different answers. That wouldn't make any sense. It wouldn't be a function. The formula would fail. Also, we can have some graphs. Graphically, if we did something like that, we can represent them lots of different ways. Basic tables here, formulas, which we spend most of our time in formulas and graphs. That's another way we represent functions. Just one note, functions have to have only one output for each input. That's the key thing. I hope that you got that from this. Now, one more thing about this one. Let's say we change it just a bit, and we say y equals f of x. Could you find f of 0? What would that
Wait, what? There's no
mean to do?
rest of it.
It mean if y
Wait, that means this is the y-intercept.
is f of x, it says y is a function of x, and I'm asking for f of 0. Can you tell me?
Oh, wait. Is it y or x? The y-intercept is when the x is 0, yeah. Y-intercept.
What is f of 0 in this case? Okay, it is how much? 2, because it says you go over to the input of 0.
Oh,
you look
okay,
up the
we're
output
doing
for
that graph.
particular input. So here it says
Table,
find your
whatever.
input. Remember this is f of x, right? So go to your x, go to 0, tell me what the output is. Oh, it's 2. How about f of 3? What's f of 3, everybody?
9.
That wasn't everybody. I'll take it. Fine, whatever. Yeah, it just says you go to your input of 3, you find out what that output was. Typically, we'll use this in this type of situation where you have some sort of equation y equals 3x squared minus 4x plus 2. The y equals thing isn't always the best for us to represent a function. The reason is because in this class we're going to look at a lot of different functions at once, and you want to be able to distinguish between them. If I have just y equals a function, then y equals another function, y equals another function, and I say, look at the function y, you're going to be like, there's 3 of them. Which one are you talking about? We often use this type of notation to distinguish between them. So
Oh, that's why you use this.
if I said, instead of y equals f of x, y equals that
Makes
function,
sense.
I want f of x, or g of x, or h of x. That way we can distinguish between those graphs and those formulas and these equations. Also, what it lets us do is if I ask you to plug in a number, it will tell you inherently what number you plugged in. For instance, if I say for you here, can you find me f of 0? Well, what does f of 0 do? What's that supposed to do for you?
2.
Oh, so supposed to plug in. Okay, supposed to plug in 0 and find out what the output is. Can you plug in 0 here?
Yeah, 2.
Okay, so you said 2. Okay, so you plug in 0, 0. Yeah, you get the 2. What's nice about this is if you plug in 2 from this one, well, you're going to get y equals 2. But does this tell you what you plugged in to get the 2?
No.
Does this one tell you what you plugged in to get the 2?
Yeah.
Yeah, this actually will give you a coordinate point. It will say you plugged in 0, you got out 2. And that's kind of nice. This is one other reason why we use that function notation. Let's go back to those graphs too. Can you tell what is a function just by looking at the graph?
Yeah.
So for instance,
This would be the what's it called? I already forgot. Are you kidding? Am I learning anything? What? Angle of inclination. Right here. So. Alright, that's 10 minutes. Do I quit? Yeah, it's GG's. Alright. Next stream. More.